So our next example asks us to find all the points where the tangent line is horizontal. If the tangent line is horizontal, what does that tell me? Slope is 0. To get the slope, we do the derivative. So exponent comes down, subtract 1 from the power, so we get 4x to the third minus. Can I go ahead and multiply these as I bring it down? Am I going to lose it? Okay, so 6 times 2 is 12, x to the first, and the derivative of 4 is just 0. And I want this to equal 0 because a horizontal line has a slope of 0. So then we could factor out a 4x. So if we solve these, we get x equals 0. And plus and minus radical 3. So those are your x's. I asked for the actual points, so like ordered pairs. So this tells me we will have a horizontal tangent line 3 times. How would I get the y's? Plug it into the original equation. So if you plug in a 0, you get 0 minus 0 plus 4. So 4. If we plug in a radical 3, radical 3 to the 4th. So radical 3 times radical 3 would just be 3, right? And I have that twice, if you think about it. So these two give me 3 times, these two give me 3, so 3 times 3 is 9. Minus 6 times the square root of 3 squared, so that would be 6 times 3, which is 18, plus 4, so negative 9 plus 4 is negative 5. Last one, what happens if I make these radicals a negative? Does anything change? A negative to the 4th is still positive, and negative squared is still positive, so we get negative 5 again. So I might ask you to find when a tangent line is horizontal. So you have to do your derivative, set it equal to 0. And if I ask for the actual points on the graph, then you have to plug your x's back into the original. Let's look at the next example. So the equation of motion of a particle is this. S is measured in centimeters and t in seconds. Find the acceleration. Okay, this is my position. How do you get to the acceleration? Right, the first derivative gives you velocity. Second derivative is acceleration. So we're starting with position, so velocity is the second, or the first derivative. So if I did this derivative, 3 comes down, 2 times 3 is 6, t, subtract 1 from the power, minus 5 times 2 is 10, t, subtract 1 from the power, so just t to the first, plus, what's the derivative of 3t? The t would become a 1, so it's just a 3. Plus, what's the derivative of 4? 0. So there's my velocity. So acceleration means second derivative. So we just do it again. So 2 times 6 is 12, t to the first, minus, what's the derivative of 10t? 10, and the derivative of 3 is 0. So that's the first question I asked for. Then what's the acceleration after 2 seconds? So that just means your time is 2, plug in a 2. So you get 24 minus 10, which is 14. Your position would have been centimeters. Velocity is centimeters per second. Acceleration is actually centimeters per second squared. That's the notation that we see. Questions on that? What I want to talk about just a little bit now is an exponential. So an exponential is something like 2 to the x power 5 to the x. It's when the variable is in your exponent. We are going to look specifically at e to the x. So first of all, e is a magical number that up until this point we just knew it was a button on a calculator. It actually has to do with calculus. It's the number so that when you did this derivative, so if you did the limit as h approaches 0 of e to the h minus 1 over h, it equals 1. Okay, that's where the number e comes from. I'm not going to test you on that, but in calculus, we are going to prefer to use e's over any other exponential because their derivative turns out to be nice and pretty. And so it's much, much easier to work with. I just put a couple graphs just to remind you kind of what these things look like. They have a horizontal tangent line at 0. They always go through the point 0, 1 because anything to the 0 power equals 1. So those are a few of them. E to the x is special because when x is 0, the slope of the tangent line is 1. That's what that previous graph or previous box was saying. But what you need to know is e to the x is really nice because the derivative of e to the x is e to the x. The derivative does not change it. So that is the thing that from now on we will accept as fact. Derivative of e to the x is still e to the x. So let's do a couple problems involving those. So here's my function. I want to find f prime and f double prime. So f prime, the derivative of this. What is the derivative of e to the x? E to the x minus, what's the derivative of x? 1. That's your first derivative. Second derivative would just be the derivative of this. So what's the derivative of e to the x? Minus, what's the derivative of 1? 0. What would every derivative after this be? If I did third, fourth, fifth, they're all going to be e to the x. It won't change anymore. I asked you to just compare the graphs of f and f prime. So this is just kind of looking at our graphing calculator. We've talked about the graphs of derivatives, how they're related to the original, and we're going to just keep revisiting that periodically. So my original was e to the x minus x. And my first derivative was e to the x minus 1. So we can see the original, it starts out decreasing, so its derivative would be negative. Then it switched to increasing, so derivative is positive. This is when it should be 0. So we have negative, 0, positive. So it still follows all the same patterns. When the function's decreasing, derivative negative. Function increasing, derivative positive. If we looked at this red one, this one's always increasing. So that means the derivative of it would always be positive, which is what e to the x will do. Okay, a couple more. At what point on the curve y equals e to the t power is the tangent line parallel to the line y equals 2x? What does parallel mean? Same slope. What's the slope of this line? 2. So I'm asking when the derivative will equal 2. So derivative of e to the t is still e to the t. And I want that to equal 2. Okay. Bring back some memories from college algebra. Do you guys remember what we add to cancel out that e?
No.
Yeah, we add a natural log to each side because a natural log and an e cancel each other out. So your t has to be the natural log of 2. If I wanted the ordered pair, then that's like your x value. To get your y, you plug that into the original. What happens when you have an e and a natural log? They cancel, so we'd get our y value to be just a 2. Just going to do 2 more, just practicing with derivatives, and then I'm done. So, just like we talked about yesterday, and we talked about with that little handout to start class, sometimes you have to rewrite this. How would I rewrite 1 over x to the, or 1 over the cube root of x? X to the negative. Okay. So x to the negative 1/3, derivative, the negative 1/3 comes down, x, subtract 1. Negative 1/3 minus 1 is negative 4/3. Plus, what is the derivative of e to the x? E to the x. Plus, I said x to the e. Okay, x to a power, the power comes down. Keep your x and you subtract 1 from the power. So my power just becomes e minus 1. What about e to the 3rd? There's no x in that. E to the 3rd is a constant. So the derivative is 0. Trick question.
You didn't say it.
No, you didn't know.
We'll say it with confidence next
Well, I
time.
don't
All right, last one. We need to do some algebra here. This is a mess. Okay. So let's deal with this. We have x squared times the cube root of x. So that's like x squared times x to the 1/3. So what do you do with those exponents? Add them. So 2 is like 3 over 3 plus 1 over 3 would be 7 over 3. This one, we have x times the square root of x to the 3rd. That would be x to the 3 over 2 power. So if you add x to the 1st, so 2 over 2 plus 3 over 2 is 5 over 2. Minus the square root of 2 squared would just be a 2, x to the 2nd. On the bottom, when you have a power to a power, what do we do? So that's x to the 4th. So then, if we divide, what do we do with our exponents? Subtract. So 7/3 minus 4/3 would be 3 over 3, or just 1. Okay, 5 over 2 minus 4 over 3. So that's like 15 over 6 minus 8 over 6. That's x to the 7th, 6. 2 minus 4/3, so that's 2, that's like 6 over 3 minus 4 over 3 would be 2/3. Now we are ready for the derivative. Derivative of x is 1 plus x is 7/6, so the 7/6 comes down. X, subtract 1 from the power, so that would be 1/6. Minus 2 times 2/3 is 4/3. X, 2/3 minus 1, be negative. So simplify first. We can only do the derivative if we have terms added and subtracted like these. So that is the end of the section. Yesterday I gave you the first part.